So hello guys, today we are going to do a lit code question that is a very famous one and that involves the basic of binary trees. Okay, basics of binary trees, the concept that binary tree is built on. Okay, like it is a traversal method. If you know what a traversal is, basically it is simply iterating over the tree. Simply iterating over the tree. So if I want to iterate over all the trees, this is one of the method by which we can iterate the tree. Okay. So what is the question title? Binary pre-order traversal. Okay. Binary pre-order traversal. Okay. So it is given that the root of binary, you are given the root of the binary tree and you have to return the pre-order traversal of its node as the problem statement says. Okay. So, so what I'll do is I'll tell you what a pre-order is. Okay, first I'll tell you what a binary tree is. Binary tree is which consists of a root node, and two child nodes. Two child node. Each node, each node, where each node has maximum two nodes, with two child nodes, where each node has maximum two child nodes. So it is known as a binary tree. It is known as a binary tree. That is like it has some variations but it's not needed for the question, so I'll make a separate video on what are the types of binaries. But any node which has any type of tree which has which has any type of tree which has maximum two child nodes is known as binary tree. Okay. So, so if I want to know what a pre-order traversal is. Suppose this is the root node. Suppose this is a root node. What what I do in pre-order traversal? What I do in pre-order traversal is okay. I first I first go to that element. I first check the first element of that. I'll check the element that I am on currently. I'll check this element first. I'll check the element that I am on currently, and then I'll go towards the left, and then I'll go towards the right. Okay, and I'll do this recursively. Like I'll first check this element. So if I order them, if this is my answer, that stores my array order, that stores my traversal order. And if I label the nodes by 1, 2, and 3, okay. And if I want to do the pre-order traversal of this, pre-order traversal, so I'll first come to the first node. Okay. I'll just simply save its value. Okay, and I'll go to the left node. Okay. So this node has become non-existent for me. Like non-existent means this is done. This is done with this work. I'll come to the left node. I'll come to this node. Now that the node I am on currently, I'll save its value. Okay. To to get saved, I'll try to come on the left node of this. Okay. First we'll travel left. First we'll check the current value. We'll travel left and we'll travel right then. Okay. So as I can see, there is nothing. So I'll return. I'll go to the right hand side. I see that there's nothing. I'll return. Okay. This is done with its traversal. This part is done with its traversal. So I'll go back. Okay. Now I'll go to the right hand side. Okay. And then I'll mark this current node. In my array. I'll store it in my array, in my traversal array, and move towards the left. Okay. So there is no node. I'll just simply return. I'll move towards the right. There is no node. I'll simply return. Okay. So this node is done. These nodes are done. These nodes are done. So I'll simply return. And I have come to a place from where I started. So this point would be my ending. Okay. This point would be my ending node. This node would be my ending node. Okay. So this is what I get as the traversal. Basically, Basically, if you are given with three nodes, what you do is, I'll break it out into three steps. Check current node, traverse left subtree, traverse left subtree, traverse right subtree, traverse right subtree. Okay, traverse left subtree and traverse right subtree. Sure. So this and this. Okay. So I'll check the current node, I'll traverse left, I'll check the current node, travel left, return back, travel right, return back, return back. I'll travel right, I'll check the current node, return back, I'll check the current node, I'll see the left node, return back, I'll see the right node, return back. So what I can say is, it is my ending condition. Ending condition is, if there is not any node, if there is no node, then simply return. If there is no node, then simply return. Okay, there's no node, then simply return. If I take one more example, 2, 3, 4, and then 5. So as I do the pre-order traversal, this is my answer array that stores my traversal order. Okay, I am on my current node, I am on my root node as of now. I'm on my root node, I'll just store simply the value that I'm currently on. I store this. I'll move on to the next. So I'm at the second node right now. I'm on the second node right now. As I'm on this node right now, I'll just simply store it. So 2. Okay, there is nothing to the left, nothing to the right. So I'll first go left, I found nothing, I'll return. I go to the right, I found nothing, I'll return. Okay, this node is done, I'll return. Now I'll go to the right hand side. Okay, as I come to 3, I'll just simply store it. As I am on the current node, I just simply store it. I go to the left node. This is a new node. I'll just simply store it. I'll go to the left node. There is nothing. I'll return. I'll go to the right node. There is nothing. I'll return. I'll go to the right node. There's a new value. I'll just simply store it. I'll go to the left node. There is nothing. I'll return. I'll go to the right node. There is nothing. I'll return. So this is the traversal order that I get. So there are basically 3 rules to follow. New node, push, go left, third, go right. Okay, so these are the 3 nodes to be followed. Go to the left subtree and go to the right subtree. So as we are doing the same things again, so this thing will be done by recursion. Recursion will do these things for us. We don't have to do this again and again. Suppose if for the current node if for the root node I'm writing that go on the left and right. So when I come to this node, this becomes my root node. So it pushes this value and goes to the left and the right part respectively. So and this is repeated for every step. So what my code says, I'll just simply add my current value first. Then I'll go towards suppose my function name is helper. I'll go towards roots left and then I'll go to roots right. So I'll just simply push the value, go towards the left and then go towards the right. Okay, so this would be my sequence. If I try to write the code for this, suppose I am making a special function. I'm making a new function, and what I'll return is my answer, and I'm passing this answer to my function as a reference. That means the values will be directly manipulated. What is my stopping condition? If there is no root, then simply return. Okay, and what are my traversal conditions? First, I'll just simply add it to my list. I'll go to the left node. I'll go to the right node. Okay, and I'll just call this function and I'll return my value. So this is my base condition and this is my traversal condition. Okay, so if I try to run it, okay, I'll just have to pass nums, sorry, answer, and in this also I have to pass answer. Okay, as I'm passing this array right to the function. So like this, if I try to submit, yeah, it is submitted. It is submitted. Okay, so as we can see that what I'm doing right now is I just simply check for condition before traversal. I just simply add a condition that if there is no node that is existing, if there is no node that is existing, if there is second node that I'm traversing on is null, then I simply return. Then I will simply return. Or if this is my first node, this is the first node that I am traversing this node the first time. Traversing the node this first time, I simply push it. I simply push it. Then I go to the left part and then I go to the right path. Okay. The question will do all of this for us. Okay. So this was the solution of the question binary pre-order traversal. If you have any doubts regarding this question, you can just ping it in the comments. And if you do like this solution, just like, share, and subscribe. Okay. Thank you. Bye bye. Have a good day.